Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to this course on circular economy for sustainable buildings. In the last class, we saw what is circular economy very briefly. We will continue with the same in this class also. So, in this class, we will now first see what is the need for circular economy. So, we need circular economy because it is essential to address the challenges of the way we are depleting our resources, the way we are generating waste, the way we are handling this waste, because of which there is immense environmental degradation. Because we are looking at take, make, dispose model. What happens when you have too much waste? What are we doing these days? We collect the waste and this waste is normally dumped in a waste ground, which is actually land which is getting polluted. The land loses its fertility. If it is a wetland, then we lose the lung of the city, which is actually very important to percolate rainwater and then make our aquifers better. Also, when it rains on this landfill where we dump the waste, that water which seeps inside the land is extremely polluted and that can also pollute our aquifers. So, a circular economy is necessary because it can make us alert and it can consciously make us to conserve our resources. We can reduce our waste, and because of all the environmental degradation that is happening because of the waste, we can prevent all that and we can also mitigate climate change by promoting a model where we can reuse, recycle these waste and also move towards a sustainable design. So, this approach not only protects resources such as land, water, but it also protects our biodiversity. It also creates a lot of economic opportunities because we will now start getting newer markets. So, what are we saying in circular economy? If a particular contraption is does not work, don't throw it away, repair it, which means we will also need many skilled personnel to understand and repair those products. We will need skilled personnel for recycling. So, there is a lot of opportunity for employment, innovation. This can be done also by fostering energy efficiency and resilience against the supply chain disruptions. This also aligns with the growing consumer demand for sustainability and ensures compliance with many of the environmental regulations. Ultimately, we need circular economy because it offers a pathway to a sustainable future while still meeting the ethical responsibilities of the future generation. If we break this down to numbers about how much damage we are causing to the environment because of our linear economic model, which is largely prevalent today, we can see that 45% of carbon dioxide emissions occurs at the production stage of most of the materials. Manufacturing and production of everyday materials is a large quantity and that is adding to 45% of CO2 emissions during the production stage. 22.2 billion tons of biomass is annually harvested to feed the global population every year. That also means we are also creating a lot of waste from this biomass, because all that is produced is not consumed also. 87 of carbon dioxide emissions from fossil fuel burning because of coal, natural gas and oil. So no, using fossil fuels is also enhancing our CO2 emissions in a very bad way. Only 9.3 billion tons, or just 9% of plastic, is captured and recycled in the world. Now, if you see, when we harvest food, here as I said, when we harvest food, 2/3 of the materials harvested and 1/3 of the food that we actually grow is rotten, and it ends up disposed like this in a landfill. So we should try and curb these wastes. So why should we do that? What is the importance of circular economy? Now, if you look at the importance of circular economy and the true principles of circular economy, the principles of circular economy, as I had previously mentioned to you, largely lies on reduction of our reliance on non-renewable sources of energy such as coal, petroleum and then natural gas. Also, the second most important agenda is to minimize the waste. So, its scope actually covers a variety of other principles that we will be considering in this class also as part of true circular economy. So, what happens because of following true circular economy? We can have resource conservation, then most important next one is we can reduce waste generation, then we can create a lot of economic opportunities. I told you how we can create economic opportunities, because we will need skilled manpower to repair and recycle products. We will reduce the environmental impact which is happening in a bad way or a negative way, and then we can also create resilience and build in national security towards the products that we manufacture and produce. So, what are the true principles of circular economy? First is zero waste. So, a circular economy will always aim towards achieving zero waste. Second is there are biological or technical cycles which I have already explained in previous classes. So, materials and components used within a true circular economy will either be part of a biological circle, which means it will get biodegradable, or it will be part of a technical cycle by which we will be recycling and reusing the a product which is considered a waste. Third is, this is important for designers because you will start trying to design for the future. So, we will look at products to last with recycling, repairing or upgradable options as a key feature. So, the product should also give us that opportunity where we can upgrade it or we can recycle it, and in this case designers have a huge role to play because they would start designing products for no circular economy rather than a linear economy. Fourth is sustainable energy. To ensure that the manufacturing cycles are sustainable, we will start focusing more on renewable energy sources rather than non-renewable energy sources. Fifth is consumers versus users. So, consumers should be reimagined as users. So, you don't consume a product and throw it away. You use the product and you pass it on to the next generation. So, products and materials should be thought of as leased to the user rather than sold to the consumer, because it will keep on moving and getting passed on to the next generation. Sixth is regenerating natural systems. A true circular economy should focus on regenerating natural systems that are previously depleted. And seventh is we should preserve what is already made. And by doing this, we should ensure that the life of any product that we use is optimized and extended. So, anything, even if it is a small can, Coke can, or any no a soft drink can, look at a repurposing for it. So, these are the important principles of circular economy, and the importance of circular economy is that it leads us to at least these 5 things. Now, I had told about the technical cycle and biological cycle. So, what are these two important cycles for circular economy? Which means when you make a particular product, it should fall into either one of this. Biological cycle is the one where we would end up the waste, the so called waste. I really feel bad to use the word waste because actually there is no waste, it's just misplaced resource. So this so called waste will get biodegraded and it will actually start improving the soil quality because of composting. Materials such as those are, they fall under the biological cycle. Whereas under the technical cycle, materials which can be repaired, reused, recycled and again goes to the manufacturing plant, they will fall under the technical products. So, normally biological cycle products are biodegradable because there is involvement of decomposers, soil components, plants, animals and so on. So, examples of these could be any of the dairy products and so on. Whereas, if you look at the technical cycle service products, they could be any of the appliances that we use, for which you actually need to extract material, process it, and once you process or manufacture it, you use it, it gets repaired, you reuse it or recycle it and so on, and the cycle continues. So, the progressive changes to the manufacturing will affect different types of products in different ways. So, we saw in the biological cycle, the raw materials are ethically and sustainably sourced from nature. They can be sourced from earth, plants and animals, but the sourcing has to be very ethically done. These products are used before any waste is decomposed and it returns to the earth as compost. But in the technical cycle, the raw materials are refined or manufactured to ensure longevity and also ease of recycling. It is designed so that it is repaired and recycled easily. These products are then used before the materials are recycled or individual components are reclaimed and reused. In both these cases, the energy used in manufacturing will come from renewable energy source only. It could be anything, it could be solar power or wind power. In some cases, the products could fall under both biological as well as technical cycle. A case to that point is, say, plastic bottles which are made from biodegradable plastic materials. So, you should design these to refill many times before we say that this bottle is no longer of use and we want to decompose it or we want to consider it as a waste. Since there is no waste in the concept of circular economy, this so-called plastic bottle which you think is no longer functional will go as a decomposed product as part of the biological cycle. So, this is the basic working of a circular economy when it comes to how after we get a product, we tend to dispose it. But then there has to be a lot of transition from linear mode to circular mode. So, that cannot be done overnight, but definitely there are some strategies, especially in today's modern world, because of which we can make this transition from linear to circular model quite seamless. First is digitalization. So, you need to start making an inventory of what is going in the product, what is coming out of the product, and digitalize it so that you now have the numbers ready with you. Second is innovation. You have to be innovative if you want to move towards circular economy. You have to be innovative about the choice of the raw material that you use, innovative about how you procure that raw material, innovative about how you manufacture that raw material, about how you design that raw material so that even if there is a repair, you don't have to throw the entire product, but you can repair only the part which is damaged and again use that product. Third is, you need to make a shift to renewable energy. We can no longer depend completely on non-renewable energy sources such as coal or natural gas, oil. We just can't afford to. And actually it is not so necessary also. India is a tropical country. There is enough sunshine. There is lot of solar energy that we can actually tap, and therefore we must shift to renewable energy sources. Then this part is very important where we as architects and designers also come in. We should start designing for circularity, which means we should start reconsidering the material substitution. What material am I using for this particular gadget? We should also try to move towards modular product design so that in the large picture of that product, if something is not working, you can remove only that module and replace it with a new module, and the old module which is taken out, you can start repairing it. You should also consider using biodegradable materials so that the product that comes out when we look at the circular economy, it could fall either under the biological cycle or technical cycle. Then we should try to recycle the product as much as possible. We should start encouraging all this. What will you recycle? For example, when a building is brought down, we can start salvaging most of the products. Not necessary that we have to salvage only windows and columns and things like that. We can even salvage bricks. You see, brick is a material which is actually not decomposable. We still have a lot of terracotta left from even Paleolithic era or Neolithic era. If you see any historic excavation, you will see a lot of terracotta products coming out. That proves that terracotta is not that biodegradable. So you need to start looking at products that are biodegradable and recyclable. Then we should look at refurbishing and remanufacturing. So a product which is repaired, we should start making it work through remanufacturing, and we should use minimum resource possible. Try to reduce your resource, and then you should start reusing the product. Do not throw and discard the product, but start reusing the product. Also start to look at resource sharing. Share the resources well. Look at structural and behavioral transformations. Also consider zero waste initiatives in any of the product that you design or any of the projects that you are involved in. Promote secondary markets for reuse of the product. So if a product gets damaged, try to create a market where this damaged product is actually the primary material of that secondary market. Then have community based recycling initiatives or circular economy hubs or micro factory models. All of these are social initiatives. Get into consumer awareness and engagement. Start capacity building through policy advocacy and compliance on the importance of circular economy. There is no shame in reusing a material. There is absolutely no shame. You are contributing your small bit to the environment. And then look at eco innovation partnerships. Don't try to have the war fought in a solo manner. Look at eco innovation partnerships. Focus on strengthening of reverse logistics and look at extended producer responsibility. When you manufacture a mixie, don't think your job goes only with delivering that mixie and telling him that we guarantee that it works for 1 year. No, your responsibility should go beyond that. Your responsibility should go even to provide service. So product as a service, you should start servicing sector should become much stronger. So if there's a repair to the mixie, you can go to the service personnel and get it repaired rather than discard the mixie and buy another new one, which is actually happening today. So in order to save our planet, we should start eliminating the use of virgin raw materials in the manufacturing sector, and we should start optimizing product design so that we can manufacture wisely. Also, we should look to explore alternative consumption. So, instead of an energy intensive material, try to look at an option which is less energy intensive. Optimize the distribution, don't focus only in one particular area or domain. Try to prolong the use of the product as much as possible. Explore service models. This is an area where we can have a lot of employment generated and it's an economic opportunity. Facilitate its repair, same as this, and develop revenue streams from waste. So a waste is not something that should be dumped on the landfill, but it's actually a source of revenue, and how we can do it, figure that out. In order to be holistically circular, what are the strategies that any human being on earth should follow? If you see, the first is R0. So we are going to look at 9 strategies. So we will look at an R9 model, which is 9 R strategies for circular economy. So the R0 strategy is refuse. That is, prevent the use of raw materials. Because, say, in the words of Antonio Vizquia Abdo, who is the sustainability advocate at Mexico City metropolitan area, he says that the transition to circular economy will require more than just recycling. It calls for a systematic shift in how we perceive design, how we get into the business of producing, and how we manage products across their life cycle. So there is this 10R. When I say R9, I mean R9 plus 1, which is refuse. So there is no action is a great action that way, and that comes to R10 strategies. So in these 10 strategies or framework, the first one is refuse and the second is rethink. So this first two, R0 and rthink, this will fall more into redesigning a business model itself, because these are high impact upstream actions that addresses the root cause of waste and inefficiency by eliminating unnecessary materials and reimagining how value can be derived. So basically what it actually means, it means that refuse to have a new product and make the product use more intensive. So it means avoid the use of materials, products or processes that generate waste and are not aligned with circularity. Also, R1 means redesign how value is created by shifting towards models that prioritize access, performance or shared use. Now, how can we do that? What are the actions for this? So, for refuse, the action is you phase out non-essential or non-recyclable materials completely. You eliminate low-value, short-lived product lines. You reject supplier practices that conflict with circular goals. I will give an example of this, which is a simple ballpoint pen which is designed to be use and throw. Completely unnecessary to design a ballpoint pen as a use and throw if it is not recyclable. It's a necessary device. We all need it, and therefore so many of us are using it. So should we use it that way, where we use and throw it? Of course, there are many other products. We can look at toothbrushes, plastic toothbrushes which are kept in hotels or many other places, even in our bathrooms, which is just a use and throw product. Imagine the number of toothbrush that the world must be throwing. If you just look at how many toothbrush you yourself are throwing, and what happens to all that, that goes into either the landfill or into the sea as a waste. Then when it comes to R1, which is rethink, you offer product as a service or leasing models, which I have already discussed earlier. You redesign offerings to meet the needs with less number of resources. Also, use digital tools to enable sharing or predictive maintenance. So, you will know when that particular product is going to get damaged or repaired. Then we will look at R2, which is reduce. Reduce means what? Consuming fewer natural resources and materials. And R3 is reuse, which is the product is reused by another consumer while remaining original functions. So this R2 and R3 focuses on operational efficiency and use of the product for an extended period of time. They involve minimizing inputs and keeping the products in circulation for a longer period of time. These strategies are cost effective and relatively easier to implement, and they still deliver measurable benefits in resource saving and product longevity. So, what is R2? R2 involves lowering the volume of materials and energy use throughout the business activities. How can we take actions on this? We can implement resource efficient production processes, we can minimize packaging size and weight, and we can use data to optimize resource planning and inventory. Whereas for R3, which is reuse, it means we extend the product life by enabling multiple use cycles without major transformation, and this can be carried out if we introduce reusable transport and storage systems and establish collection and deployment processes for used products. Also, we can design products with durable components. Then we will have the next R, which is the fifth R, but called as R4, which is repair. So, when a product gets damaged, please either maintain or at least repair the product. And this becomes important because this is also aligned with R5 refurbishing, which is restore old product and bring it up to date. So, this R4, which is repair, and R5, which is refurbish, this will introduce mid-level interventions, because both of this will aim to maintain and improve the performance of the product beyond its initial use. This can delay the need for new production and reducing environmental burden. These strategies require supporting services and infrastructure, but they can definitely generate new revenue models and increase the loyalty of the user or the so-called consumer, because in circular economy it's better not to use the word consumer but to use the word user. Then repair means in R4, which is the fifth R, you maintain and fix products to extend their usable life by avoiding premature disposal. This can be done by providing repair services or instructions of use to clients. We can also maintain spare parts and service networks and include repairability in product design and procurement criteria. The sixth R, which is refurbish, and R5 is update and improve used products for resale or extended use within retained value. How can you do that? You can do that by establishing internal refurbishment protocols and source and resell refurbished equipment. We can also integrate refurbishment options into after sales services. Then the seventh one is remanufacture, which means use parts of discarded production in a new product with the same function. And the eighth R or R7 is repurpose. It means use discarded product or its parts in a new product with a different function. So, this R6, which is remanufacture, and R7, which is repurpose, they go a step further because they transform or change either the components of the product or the total product itself for a new and renewed function. So these actions often involve more technical and logistical complexity, but they offer higher value recovery and help build more resilient supply chains. So what is this R6, which is remanufacture, that we are talking about? It means you rebuild the products using a combination of reused, repaired and new parts to get original or better condition. This can be done by developing modular product architecture and recover and remanufacture key components, also by setting up reverse logistics for component return. The eighth R, or R7, which is repurpose, looks to reallocate used materials or products in order to serve a different function on the entire value chain. This can be done by identifying non-functional products for an alternative use. For example, a soda can as a flower vase, repurpose surplus or obsolete inventory, and collaborate with partners for secondary applications. Then we have the ninth one, which is R8, called as recycle, which is salvage material streams with highest possible value. And we have the 10th R, which is R9, which is recover. So incinerate waste with energy recovery. And this recycle, or R8, which is the ninth R, looks to recover materials at the end of their life to be reprocessed into raw inputs. Now, this can happen by designing products and packaging for recyclability, and also invest in segregation like sorting, separating and recycling systems. It can incorporate recycled content into the new product. Whereas the 10th R, or R9, which involves recover, this means extract the energy or materials from waste that cannot be reused or repurposed or recycled. This includes waste to energy and other forms of resource recovery. This can be done to convert non-recyclable waste to energy through certain known, certified, acceptable, endorsed processes. So, the partner with industrial symbiosis or recovery will facilitate this, and you use data to maximize unrecoverable waste and maximize material recovery. So, the recycle R8 and R9 recover are essential but should not be considered as the last resort option. They focus on extracting raw materials or energy at the end of the product's life cycle. When nothing can be done, we resort to R8 and R9 because they focus on extracting the raw materials or energy at the end of the product's life when there is no other value preserving strategy possible. So, this is widely adopted and they often involve energy intensive processes and they deliver lower economic and environmental returns as compared to other upstream actions. What makes this 10R framework powerful is that this aligns business priorities with circular principles at every stage, right from eliminating waste at the source to recovering the value at the end in the form of energy. Each of these R strategies help companies take actionable steps based on their current capabilities and ambitions, and that makes the R10 which is the strategy for circular model really comprehensive and more sensible. Let us now see the role of circular economy in resource optimization. So, there are key aspects of circular economy when it comes to optimizing resource. First, I have already mentioned all of these, but I am reiterating it now in a different way. The first is resource efficiency. So, when you start designing products for long life, or to enable them to be repaired or even recycled, the circular economy will minimize the need for virgin new raw materials, thereby it will conserve our natural resources. And this efficiency will reduce the burden on the environment and prevent environmental degradation. Second is waste reduction. So, when we start applying circular practices, we can definitely reduce waste significantly. Then the third is economic opportunities. When you start moving towards circular economy, you can definitely see a lot of economic benefits by being very creative in generating economy or generating employment. And then fourth is innovation and competitiveness. So, when you adopt circular principles, it can actually foster innovation in product design, in various business models, and also in how you create this supply chain management. Companies should start adopting circular economy, and they should also understand that over a period of time they can actually gain a lot, because they can meet the growing consumer demand for sustainable product and practices. So, we need circular economy, and we can also generate circular economy by appropriate selection of materials, raw materials, by actual design which will give us an opportunity or scope for repair. Also design products for life extension. If you actually see your grandfather times ceiling phone will your grandfather times ceiling fan will still be operational. Even that phone that your great grandfather used, which is the dialing type, that black one, I'm not sure how many of you had even seen that so far, that still works. But our cell phones, within 1.5 years, they go cuckoo. So, look at product life extension and try to look at packaging waste. Do we need so much of packaging and cardboard? Relook at all that and be very transparent about what you are delivering. What is the lifespan of the product? How repairable it is? How reusable it is? And give clear instructions to the users about what to do when you want to dispose the product. And therefore, whether it is recyclable. Try to create and also have social responsibility. Look at transportation energy and overall business model. Start engaging with customers and also look at end of life management of that product every time you design a particular product. And then last but not the least, energy efficiency, and all of this will go a long way in energy management, resource conservation, sustainable sustainability, and reducing climate change. So these are all the impact of actions such as this. So if we look at circular building materials as architects, we should start looking at life cycle assessment. Life cycle assessment is a very validated science-based tool which starts quantifying the impact in order to assess the lifetime environmental repercussion of that building material. So, life cycle assessment takes into consideration all the steps and angles that lead from raw material, extraction, transportation, manufacturing, distribution to the site, erection, use, retrofit and final disposal. As architects and designers, we should start considering this because we need to look at the benefits of conducting life cycle assessment of buildings. By doing that, we can reduce the environmental impact by evaluating the building site options to choose a site which will have lowest impact. Then you should start comparing the environmental impact of renovating rather than demolishing and building completely new. You should start comparing your design alternatives to choose the one which gives the lowest impact. Then you should start identifying the environmental hotspots and you should start taking action to reduce the environmental hotspots. Further, calculate the lifetime impact of building materials and products in order to find the most sustainable options. And then I am slowly introducing another concept which is material flow analysis or MFA. MFA or material flow analysis is a systematic assessment of the flows and stocks of materials within a system defined in space and time. What is it? We will be seeing it in later classes. So, if you look at material flow in terms of a linear economy, you can see that in a linear economy, the raw materials will be extracted from earth through mining. It is manufactured as a material or a product. Then you start assembling it. Then after its lifetime, you start discarding it as a waste and it gets disposed. At the most, when you manufacture it, you could probably repair it if it has an issue. If it is not repairable, again it gets disposed. And waste generated through manufacturing is also disposed, and this goes to the elements of nature and pollutes the elements of nature. So, this model is again characterized by take, make, dispose approach, and it is the most unsustainable model because there is resource depletion. You are taking away so much resource and you are throwing it away as a polluted, as a pollutant. Anywhere you want, pollutant to air or land or water. And so it is a highly unsustainable way. So do not use building materials in a material flow of linear economy. Rather, try to look at material flow in a circular manner. So use circular building materials, where what you do is, in a circular economy where you use building materials, you use material flow as a movement of material into, through and out of the system. So what you actually do is, you start either from a recycled manufacturing process and send it to the manufacturing unit, or you mine and send it to the manufacturing unit. After that, you assemble the product, and then if it gets if it has any damage, you refurbish it and then assemble it, and then start using either the assembled or refurbished product over its lifetime, When it is no longer useful and viable, you send it back for recycling and it goes back to the manufacturing plant, or you use another recycling process, and then probably you could even make another material out of it, or you can start repairing it, and eventually if it is still a waste, you recycle it. If it is a biological cycle, then it goes for composting or energy recovery. This is a more sustainable model. So, in today's class, we saw about what is circular economy, how can we actually practice or strategize and use circular economy. With this, we will stop today's class and continue with understanding circular economy in the built environment in the next class. Thank you.